this episode, we would like to say that in the spirit of reconciliation, that we acknowledge the traditional custodians of country throughout Australia and their connections to the land, sea and community. We pay our respects to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander people today.
Welcome back for another episode of Spaghettification, stretching your understanding of the universe. I'm Claire Kenyon, the red-lipped astro.
And I'm Mark Iscaro, the drunk astronomer.
And we're here to take you through some things that you might see in the sky in October, and we'll talk a bit about something massive that happened in the last couple of weeks in Melbourne, Mark.
I swear my house was going to fall down.
Oh my goodness, it was shaking like crazy. So yes, in case anybody is listening and doesn't know about the most exciting geological thing to happen in Victoria for a very long time, we had an earthquake. And so today, a lot of our focus for in-depth and shit you should know is around quakes. So I guess we should probably talk about stuff in the sky for October. So, what's up?
Planets. Planets are up.
Yeah.
What have we got? Venus setting in the west at the moment. Brightest star in the night sky.
Star.
As everyone keeps saying to people, it's the brightest star in the night sky. Get a lot of messages from people saying, what's that star in the west that I can see? And then trying to explain to them that it's a planet, not a star.
Well, I think the easiest way to find out if it's a star or not is just to simply ask you whether it's twinkling. Twinkle, twinkle,
yes.
Little star. It's a giveaway, isn't it?
If it's not twinkling, it's the planet.
That's right. So you're absolutely right. This month is fantastic for some planets. Mostly Venus is looking great and doing some really cool things. And of course, our friends Saturn and Jupiter. It's that time of the year where Saturn and Jupiter are good viewing. So as you've said, you've got Venus, our companion in the western sky at sunset. It does set a few hours later at the moment, but it's really, really bright and good to see. So going back to people that keep saying to you, oh, what's that star? And it's Venus. Well, on the 10th of October, you can say to them, Mark, is it right next to the moon? Because Venus and the moon will share the same right ascension on the 10th of October. So get out there and know that you're looking at Venus on that night. Venus also will reach its highest altitude in the evening sky on the 16th of October. So it gets about 44 degrees above the horizon at sunset. So you're looking about halfway up, which is pretty good viewing, decent viewing. It's been pretty low in the sky up until now. So that's Venus. Saturn and Jupiter are doing some fun things. There's a conjunction of the moon and Saturn on the 14th of October, followed by a conjunction of the moon and Jupiter on the 15th of October. So that, of course, means that they share the same right ascension and they look like they're pretty close in the sky. And you were telling me that something happens with all the, what do they call the horoscope people? What's happening?
Yes, because Saturn is coming out of retrograde, so they're
Very
all freaking out. I think they're all going to go and put their money on black and charge their crystals again.
Hey, look. However
Something
people
like
choose to frame their existence is up to them. So, of course, what you're referring to is Saturn ends its retrograde motion on the 11th of October, followed by Jupiter ending its retrograde motion on the 18th of October. So I don't know if you know, but the Greek word planet is where planet comes from. And they actually were called the wanderers. So they wandered around the sky. So they're not like stars where they just kind of rise and set the same all the time throughout the year and over the years. If we note down the position of Saturn or Jupiter or another outer planet in the sky at the same time each night, the majority of the time you'll notice that from one night to the next, the planet you're looking at will start a little more eastwards from night to night, which is prograde or forwards motion. But due to Earth's orbit and the outer planet's slower, bigger orbits from our perspective, occasionally we'll be situated such that it looks like from Earth, the planet we're looking at starts to move west to east from night to night through the zodiac. That is, it starts appearing a little more westwards from night to night. This is retrograde motion. It's probably not going to affect your life. And there's one last thing I want to talk about with the planets. Venus is at something called dichotomy. And I'm not talking about when you've been faced with a tricky issue.
I was just about to say, what trouble is Venus in that it's
wearing a mask,
different dichotomy?
half its face, yeah.
I know what it's got its nose hanging out, doesn't it?
Oh, absolutely.
It's
Venus
not wearing
has
its
a
mask
nose.
probably. It's
100%.
a chin mask wearer.
That's weird. I can never unsee the meme with the it's not a nose hanging out.
Yeah,
I can't unsee that.
Don't be a mask. Yeah.
So anyway, Venus is coming to dichotomy on the 29th of October, so late in the month. And what that means is that you'll actually see Venus at half phase, which is really cool. And I encourage anybody that is into astrophotography to see if you can get a shot on the 29th of October of Venus at half phase. This is not our astrophotography competition. This is just for your practice. So, Mark, you chose the Mare Tranquillitatis.
Mare Tranquillitatis.
For our moon feature of the month. So tell me about this Mare.
Mare Tranquillitatis. Well, it's a dark spot located in the northern hemisphere of the moon. I know that much.
When we say northern hemisphere...
southern hemisphere, sorry.
No. Oh, this is important to mention because when we pick up the lunar maps from anywhere, typically they show them as you would see from the northern hemisphere, right? So when they talk about the northern hemisphere of the moon, it's actually down the bottom for us.
Southern hemisphere for us.
Yeah.
I keep forgetting that.
Which is why if anybody went to go and look at Tycho from last month's podcast, they would see that the map showed it down and to the left when we were talking about it up and slightly to the right. Yeah. Anyway, so Mare Tranquillitatis.
Tranquillitatis.
That's what it is.
I know.
It's Latin.
I just love the name of it. Sea of Tranquility.
What's it Latin for?
Yeah.
Yeah, Sea of Tranquility.
Sea of Tranquility.
So with the Mare, most of them are named after either states of mind or weather patterns. So you have things like the Sea of Storms or...
And you have Serenitatis and Imbrium.
So that's a state of mind. So you've got the Sea of Crises, Mare Crisium. Mare Nubium is the Sea of Clouds. So, of course, that's like the weather patterns. There are a couple that don't conform, but most of them are either a state of mind or a weather pattern. And I honestly don't think there's any difference. There's like a Humboldt. There's something Humboldt, I think. I don't know. Anyway, but there are a couple that don't conform, but most of them do. And I think that weather patterns and states of mind are often either connected or one and the same.
Well, most people's states of mind are like the Victorian weather pattern, aren't they? Or the Melbourne weather pattern. Where they're like 1 minute they can be happy and then all of a sudden they can be angry. And then they'll be sad and then they'll be happy again.
So you're either suggesting that we have 4 seasons in one mind or we have bipolar weather.
We have bipolar weather and 4 emotions in one day.
Quadrupolar weather. Paul would love it. Paul Lasky would love quadrupole weather because that's the shape of gravitational waves, isn't it?
He would love that, yes. Yes. No, but where were we? But with Sea of Tranquility, that's right.
Oh, before we got lost.
Before we got lost. I like it because, every time I do a live stream with the guys and we have the moon on and you can see the Sea of Tranquility, somebody in the comments section will ask us, can we see where Apollo 11 landed?
Answer?
And then you have to... No. No. We can't. No, not at all. That's why I like it, but I also like it because it's an area where the 3 craters that were named after the astronauts.
Oh, so really? I didn't know that.
Yes. So on the, I'd say for us it would be the southern base, Aldrin, Collins and Armstrong.
Oh, well, I could have guessed the astronauts.
I don't know. Some people might not.
So do you know why they're called seas?
Because they look like seas, but they're not seas because they're dirt or dust or rocks or whatever they're. Yeah, you know what I'm talking about. It's the basalts.
It's not just that they look like seas. They actually thought they were seas.
We're seas, yes. Yeah. God, we were stupid back then.
It makes sense that when we look out into the sky, we look for things that are similar. But, yeah, they thought they were seas. Just like Mars, they had the cannoli, which were...
Cannolis? I love cannolis.
No, not cannolis. Cannolis are good.
Cannolis
very,
are
very
awesome.
Yummy. Chocolate and cream and choux pastry. How could you go wrong?
Just straight cream.
Oh,
no chocolate.
Yum. Oh, I'm salivating.
No, we've got to go back to it. Sorry, sidetracked by food.
Anyway, so this is Latin for sea, mare, because they thought that they were. But now I think they're absolutely just beautiful to be called seas. I don't think that they need to be real seas in order for them to be beautiful. But this dark stuff, Mark. This
basalt?
Dark stuff. Yes, it's basalt.
Dirt and rocks and dust and stuff.
So basalt is darker than the highlands, and the highlands is sort of the white stuff around the crater. The mountains, don't laugh. Don't go there.
I'll try not to.
So we've got the highlands, which are the light areas, and the basins are where basalt or flood basalt has come out from underneath in the warmer times of the moon's mantle. The mantle upwelled and actually filled these basins. And they're darker because they have a lot of iron in them. So we have a chemical difference between the higher white rocks and the darker basins.
So the other thing I know about it is that we crashed a spacecraft in there just for the fun of it. The Ranger 8 spacecraft, we just thought, oh, we've had enough of that one. We'll just smash it into the Sea of Tranquility.
Really?
Yes.
That's not very nice.
I know. What are you going to do? They couldn't get it back, so I thought, what do we do with it? We'll just crash it into Sea of Tranquility.
We do have
Yeah, if we don't like that, if we've had enough of a space probe or a rover or something, we just crash it. It did transmit over 7,000 photographs of the moon in the final 23 minutes of its mission.
Was this on an Apollo mission?
No, this is back in 65, Ranger 8 spacecraft. It was deliberately crashed.
Okay, so the lander module that delivered, what was the last Apollo mission to the moon?
18, wasn't it?
17, 18, 18? No, Apollo 17 was the last one. And they placed and used seismometers on the moon, which was what I was going to talk about later. But interestingly enough, Apollo 17, the craft that they used to get up to their orbiter, they deliberately crashed onto the surface of the moon. And then the seismometers that were on the moon picked up the crash.
I finally remember where I got Apollo 18 from some dodgy movie called Apollo 18. That's where I got it from.
I think you mean Apollo 13. It was not
No. There was a really dodgy Apollo 18 movie.
So these mare, the typical age is 3 to 3.5 billion years ago. And we talked about Tycho last episode being, what was that, 180 million years? So that's quite young. But these mare are typically quite old because the moon was around in these periods of time in the solar system where there was a lot more crap floating around and being gravitationally drawn to bodies and smashing into bodies. The Earth as well, but we don't see as much evidence on the Earth because of weathering and turnover due to tectonic activity. This seems to be the theme this podcast. So these mare are normally 3 to 3.5 billion years old. This particular basin is quite round. And it's right next to another quite round mare, Serenitatis. And so Apollo 17 actually landed sort of in between those two.
In between the two of them.
Yeah.
Yeah, Eagle has landed.
The Mare Tranquillitatis was chosen for the Apollo 11 mission because from Earth it looked really flat and uniform. But when Apollo 11 got there, well, not Apollo 11, but of course the landing craft, the Eagle, when it got there, Neil actually had to assume manual control. And then with fuel running out and sensors going wild and Houston literally holding their breath, had to navigate over enormous boulders to find a clear patch of land.
They came in at the wrong angle, didn't they?
I don't know about the wrong angle. Is that right?
I'm pretty sure they came in at a slightly off angle or were going slightly too fast or something. He had to manually readjust, yeah. No,
you're probably right. I know that basically they thought it was going to be really smooth. But they got there and the smoothness turned into boulders, turned into big problems. But ultimately they managed to land with a very small amount of fuel left over.
98 kilos of usable fuel.
Wow, that's so small, isn't it?
Not much.
Can you imagine just sitting there on that?
Look, for my car, that's a lot probably. But for the Apollo, no, that's not a lot for...
it's less than some people.
Oh, look at that. I was right. We had 15 seconds of fuel left. Some things do stick in my brain when I watch documentaries.
They get through the poisonous hair dye. I'm kidding.
My hair looks like Tarantula Nebula at the moment.
It's absolutely beautiful. I was thinking My Little Pony, but Tarantula Nebula is totally okay. But basically it wasn't smooth like they thought. And that gives you a perspective for what you were talking about earlier, and that is that you can't see the Apollo 11 site. Mare Tranquillitatis was formed, we think, by an impact. So it's now 873 kilometres in diameter, and it's a very, very large impact with upwelling basalt. It's also extremely flat. It doesn't actually vary in elevation much at all. There's about 500 metres between the highest and lowest points in the basin, not including where other things have caused craters and stuff. But itself, the flooding, it doesn't vary much at all. Not enough to do hill sprints.
So I do know it has a higher metal content. So when you do processed colour images, it will look blue or a bluish tint to it.
Is that right?
Yes.
I've never thought of that.
Yep.
Wow.
Have you seen the mining moon map that's been created?
No, I should have a look at that.
You should. It's so cool.
It scares me, though. I think human beings should stop thinking about mining.
No, they're not
things.
talking about mining. It's like a mineral moon map is what it is.
Oh, okay. Not a mining moon map. I think asteroids are a better target than the moon, to be honest, for mining.
Some of the guys keep talking about the ASV, but some of the guys one guy in particular posted a photo the other day and he had mineralized his image of the moon. He'd processed it with colour to get this out of it, and colour differences were amazing. You can really see the blues and the greys and the browns, like the rusty colours coming through some areas. It's very cool.
Oh, wow. Do you know what metal it is in the Sea of Tranquility?
Well, no. All I know is that it's just a high metal content. What metal it is, I don't know.
There's titanium in there.
Oh.
So the same stuff that we build some strong prosthetic legs, such as the one that went up in the most recent civilian launch on SpaceX.
Oh, that was cool, wasn't
it? Yeah. Yes. So one of the, I suppose you can call them astronauts, although they're civilian nauts. Let's call them civilian nauts.
No, well, see, this is the thing. I've seen people complaining about this, and I know that some of the astronauts from back in the Apollo days were like, one day we hope everyday people can go into space like we have been, and they too will be astronauts. It's like saying, are you a civilian pilot or are you a commercial pilot? You're still a pilot. Doesn't matter whether you do it for yourself or,
we're everyday people, right?
We are everyday people. Yes. Good song,
It's pretty
that.
exciting that it is the beginning of non-career astronauts. Well, there have been a few scientists that have gone up that are non-career astronauts, but certainly not just civilians, physicians, assistants, and geoscientists now going up. So that's really exciting. And I wasn't trying to be dismissive at all, but the physician's assistant actually had a titanium leg. So we actually have some meteor showers in our skies in October. There's actually a large number. There's 4 or 5, but we've picked 2 that
There's only 2 of any importance anyway, isn't there?
So when we look at ones of importance, we look for what's called the zenith hourly rate, which is basically when you account for where you are on Earth and observing how many you'll see. So we've picked 2. The second one, I'm going to let you announce that in a minute, Mark, because that's more exciting. But there's something called the Southern Taurids, which will have a zenith hourly rate, the ZHR, will be approximately 3, so that's 3 an hour from Melbourne on the 10th of October. That doesn't mean you won't see any leading up to the 10th of October or moving away from the 10th of October, but that's supposed to be the peak. So that should be the peak when you see approximately 3 an hour from Melbourne. So the Southern Taurids are actually associated with a comet called Comet Encke. And what happens is Comet Encke goes around the sun, and every time it does, it blazes its bright tail, which is of course the sun heating up and melting the ice and dust, and you see this gas tail as well. And so that leaves a path of debris. And then as the Earth orbits the sun, the Earth crosses into this debris. And I have been on the record, quite embarrassingly, I think it was in Broadsheet, saying it's like driving through a field of bugs. You go boing, 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 splat. Splat, splat, with the meteors hitting the atmosphere of Earth as the bugs on the windshield. But I was quoted word for word, which wasn't really what I had planned. But never mind. So Earth going through this...
I'm going to go and hunt for that now, and I'm going to go and share that on
Everybody will.
Yep,
it was very embarrassing. I was like, surely you're going to paraphrase this, but it didn't happen. So Earth going through the dust and gas and crap cloud is much the same as driving through a field of bugs. So the Taurids are so named because they emanate out of the constellation Taurus, but they're nothing to do with those stars at all. It's just that that's where they appear in the sky, in that constellation. When I say that's where they appear, it looks like that's where they're coming from. So if we look at the big long streaks of meteors and we track them back to the central point where they all seem to come in, that's called the radiant. And where that radiant is in the constellation is what we call that meteor shower. So the Southern Taurids are an annual meteor shower that we see, and they're in the constellation Taurus. Something really interesting about the Taurids, the Southern Taurids. So although they're called the Southern Taurids, it doesn't mean that meteor showers for the Southern Hemisphere. It actually means that it's the more south of 2 meteor showers. There's actually a Northern Taurids as well, which actually happens at the same time. They have different sources, but they're roughly located in the same location. But the Southern Taurids is in the south area. And remember Tunguska?
Yes.
Yeah, you remember Tunguska?
Yes, Tunguska.
The only reason I know about Tunguska is because it was featured in an episode of The X-Files a long time ago. ago. Then I looked it up.
That episode. Oh my God, that's so old.
So Tunguska happened in 1908.
I feel very old.
And they reckon that possibly the piece of impacting material that blew up and flattened all those trees in Tunguska was actually potentially a piece of Comet Encke, which is the same origin as the Southern Taurids, which I think is bloody cool.
That's very cool.
If you want to find the Southern Taurids, you find Orion holding his shield and see which way he is pointing. Taurus is there. So look for Orion, look for the way that his shield is pointing. There's an absolutely fantastic video showing a cloud of dust left by Comet Encke on meteorshowers.org. You go in and you type in your meteor shower and it actually shows you the cloud of debris left and it shows you the orbit of Earth and it goes through this debris cloud. So you can actually see why you get related meteor showers in different parts of the year. It's really, really cool. They're expected to reach their peak at about 9 o'clock Melbourne time on the 10th of October. So the best way to view it is, of course, to go outside. Go somewhere you've got a dark, dark, dark sky, particularly for these meteors because they're not...
Lockdown.
Go into your backyard or something. You can go 15K. You can do exercise and look at the meteors.
Oh, you can go, but then you'll be able to go 15K. Yes, yes.
So go out, have a look. You're best to not look directly at the radiant. So don't look directly in the constellation of Taurus. Look a little bit away. And that's where you'll actually see those big bright streaks left by the pieces of crap left behind by Comet Encke.
Suppose we can now talk about the important meteor shower, or one that comes from everyone's favourite comet, the most well-known comet. Anyway. Comet Halley. Orionids, or I mean, I call them mares, so can't really. My grasp of the English language is not great, but
even the word English seemed a little touch and go there.
Orionid meteor shower, which is because of the debris left by Comet Halley. When did it last visit us?
It visited in 1986 and I was 2.
It did,
and my mum took me outside to look at it and apparently it was a poor showing.
I have no idea whether my parents took me outside to see it or not.
I've never asked her whether she meant me or the comet, but you know.
Little from column A, little from column B.
Steady on.
Yeah. So the greatest numbers are meant to hit us on the morning of October 21st, but we got a bit of a problem there. We're going to have almost a full moon at that point in time, so it's going to cause some dramas.
So the thing about the Orionids as well is that it's crap left over from Halley's Comet, but it's not super recent.
No, it's old crap.
It's old crap.
It's old crap.
It's burning up the old crap. Also, what's really cool about the Orionids is they are really fast. They travel around 148,000 miles per hour, which is 66 kilometres per second into the Earth's atmosphere. So they leave these amazing glowing trains and they're some of the best Southern Hemisphere meteor showers.
They smash into us at about 100 kilometres above the Earth. That's where they hit us.
It's amazing. Absolutely amazing. They're big, long streaks. So you can see, up to 8 at the peak? 8 to 10 probably?
If someone puts a blanket over the moon, see 8 at the peak. The radiant for the Orionid meteor shower is just north of Betelgeuse, or Betelgeuse, but I call it Betelgeuse. Don't say it 3 times, though.
I think we've all grown up calling it Betelgeuse.
If you say it 3 times, a star will appear in your house, and that'll be the end of us.
Bloody Mary, Betelgeuse. What are we going to do?
Yeah. You can't win, can you?
Okay, so Mark, our constellation of the month?
Sagittarius, which lies in our southern skies. It obviously is one of the zodiacs and it represents the archer. So it's usually depicted as a centaur holding a bow and arrow. And it has an asterism known as the teapot, which for us is upside down, upside down.
It also goes right back to the Sumerians.
Yes.
And then it was adopted by the Greeks. And that's why it's actually not even that clear where this archer's identity came from, because obviously we have a big connection with a lot of our constellations with the Greeks, at least in the Western sense. A lot of our mythology comes from the Greek and the Roman times, but a lot of that was stolen from previous people.
Everyone steals everything from everybody these days.
Yeah, absolutely. So this constellation seems to be of Sumerian origin, and we're not really sure who the archer is supposed to be. According to Eratosthenes, it's supposed to be Crotus the archer.
Yes, Crotus the archer.
He was a nurse to the Muses and the inventor of archery. But this is a bit of a problem because Crotus was not actually a centaur. He was a satyr, which is a woodland creature depicted as having pointy ears, legs, and short horns of a goat, and a fondness for unrestrained revelry. We should have him on.
I was going to say, sounds like a good friend of mine.
It does sound like a really good time.
He sounds like the sort of person I'd hang out with.
So Sagittarius actually is easy to find because it lies on the Milky Way plane. So if you can find that beautiful river of stars, you can find Sagittarius. And of course, as you said before, look for the upside down teapot.
It's fairly easy to find at the moment because it's pretty much almost straight up as soon as it gets dark.
You know what I love about talking about these things? This picture in the stars was catalogued by Ptolemy. We see pictures that somebody catalogued and looked at in their sky
all that time ago,
millennia ago, and I just find that quite mind-blowing. But even that is just a tiny blip on geological scale, and then geological time scale is a tiny blip on the universe scale, and that just really just blows my mind.
So did you know that Sagittarius has 32 stars with confirmed planets?
No way. That's great.
Yep.
Probably more.
2 known exoplanets that are similar to Jupiter and Saturn that were discovered in 2008.
But Sagittarius is cool as well because it's got a bunch of other things in it, and we'll probably do some of them as our astrophotography challenge at some stage.
Oh, yeah, definitely, because it's a perfect time to do those. Has 15 Messier objects in it.
Yeah, we're talking Omega Nebula, M17, M18, Lagoon Nebula, M8, and Trifid Nebula, M20.
Yep.
So there's a large number of nebulae in
M17, the Lobster
Barnard's
Nebula.
Galaxy, the Bubble Nebula.
Yes.
Oh,
No, the Lobster Nebula.
that's a Bubble
Omega
Nebula
which
as well.
Oh, okay. Well, Lobster is also Horseshoe, which is also Swan, which is also Omega. It's also got Sagittarius star cloud in it.
Oh, yeah, it's absolutely beautiful.
Lots and lots of globular clusters and open clusters.
And it has, which is in my wheelhouse, Sagittarius A star, supermassive black hole, sucking all that material in.
That's the one that we get spaghettified around. It also has the Pistol Star as well, one of the most luminous stars known, which is a blue variable 4 million times as luminous as our sun and around about 200 times as big.
Can we just talk about that for one moment?
Yeah.
You look at the sun.
It's huge.
You can damage your eyesight.
You can.
And you said 4 million times as luminous.
Yes.
I find that insane.
Yes, so you have 2 chances to look at the sun, your left eye and your right eye. I reckon with this one, if you looked at it through a telescope incorrectly once, it'd be that bright and that hot and that powerful that you'd be dead. You'd look through it and it would burn through your body.
Oh, no, thank you. So we touched on last episode that asterisms are pictures in the sky, but constellations are ratified and recognised by the International Astronomical Union, the IAU. So Sagittarius has 17 named stars in it that are officially approved by the IAU. And they make up this Archer, Centaur, Satyr, whatever it is.
So talking about the teapot and asterisms, the Burong people of northwestern Victoria didn't see anything particular in Sagittarius, but just sort of above Sagittarius at the moment is Corona Australis, which they saw as the boomerang, which was thrown by Totiagul. And Totiagul is the star Altair, which is in Scorpio. And the Arunda people of Central Australia saw Corona Australis as a Coolaman carrying a baby, which was dropped to Earth by a group of sky women dancing in the Milky Way. And the impact of the baby dropped to Earth by Coolaman created the Goss's Bluff crater, 175 kilometres west of Alice Springs, which they believe it's the eroded remnant of an impact crater, which is known as Tnorala. I'm going to get that wrong and I apologise. I really do, to the West Australian Arenti people of the surrounding region.
Going back to, I suppose, the Greeks, when we talked about Claudius Ptolemaeus, or Ptolemy, in about 130 CE, seeing Sagittarius. But our star cluster that we're going to talk about today is actually called the Ptolemy cluster and was sort of first observed, or at least first noted down in records that we see today by Ptolemy. So M7.
Yes.
Good viewing in the middle of the month.
It is. It's a visual magnitude of 3.3 and an apparent diameter of around about 80 arc minutes.
That's huge, isn't it?
Yes. It's more than twice the apparent size of the full moon. So it's big.
Yeah.
It's a big object. It's an easy naked eye target, not in the middle of the city, but sort of rural, regional, sort of outskirts of the city into the regional areas. You can find it in binoculars in the city, that's for sure, but not naked eye. Not from my backyard anyway.
So if we want to find it, Ptolemy described it as the nebula following the sting of Scorpius.
Yes.
But we're not actually sure today whether he was referring to M7 or whether he was referring to the very nearby M6. But it doesn't really matter. Find the sting, the tail of Scorpius, and it's a bright open cluster in that area.
So the star that you're looking for is Lambda Scorpii.
Ah, is that the really bright one?
Yes, fainter only than the red supergiant Antares.
Ah, Antares, cool. So this star cluster has about 80 stars, and they're all brighter than Mag 10 in a field of view of about 1.3 degrees across. So that's quite dazzling.
It is. It's pretty big.
If you try to catch it in anything, a bit like a scope. So this open cluster is about 220 million years, and open clusters are interesting. We think that they all condense from the same molecular cloud, so they all have very similar ages. They may not be the same type of star, but they've all been born about the same time. And this is quite a young cluster, an open cluster, and we call it open because it's not a globular cluster. It's not tightly bound by gravity. It's actually just open. Like they sort of all formed by the same gas, same time, but eventually some of them will actually not stay in this cluster.
But they are still bound by gravity?
Absolutely, yeah.
What is it? The tidal radius of M7 is 40 light years across?
Yeah, so I think in my interpretation, the tidal radius refers to the effects of gravity. So how are they kept in together against other gravitational forces? Yeah.
And it's the Milky Way doing that.
Yeah. Open clusters can be very easily disturbed, and over time they do become disturbed by other massive objects. That's why they're called open clusters. They're open to anything.
So the other thing I know about M7 is that around about 10% of its stars will eventually end their life in violent supernova explosions, and the rest will gradually drift apart.
Yeah, so that's what's interesting about open clusters. So globular clusters are a little bit different from open clusters, and we should totally do this as an in-depth at some stage.
Yes.
But open clusters, because they've all condensed from the same cloud, they're all about the same age. So if we get quite a young cluster, we will see lots and lots of very bright blue supergiant stars, which is what we see in this Ptolemy cluster in M7. So they're really bright, they're blue, they're hot, they live fast, die young. And so we wait long enough, we'll actually see a whole bunch of massive stars explode in supernovae. And then the ones they leave behind, I've said this before, but the accountants, they just go on adding their numbers for a very long time and drift away from each other because, you know.
Oh, they all like spending time by themselves. They like to be alone.
That's exactly right.
So do you know what's really cool for our listeners to do?
What's that?
If they look in the area of M7 on October 14th at around about just before 9:30, 9:29 minutes and 30 seconds. But if you look probably through binoculars, or if you're looking at that area with the naked eye and you're in a dark sky area, you'll see a Starlink satellite go whizzing past that area.
Oh, that's cool. When I was a very young girl, my dad would take me out and we'd have a look at the sky. If you don't know how to navigate your way around the sky, you sort of look for things that are moving. And so it was always fun to pick.
It's a spaceship.
Yeah, well, to pick out these white dots moving across the relatively still heavens. So when we were camping, we'd often do that. We'd, at Wilson's prom or whatever, we'd look out at the inky darkness, and then you'd see this amazing backdrop of many, many stars, and then just this white thing go past. And yeah, I learned that was a satellite. I'll bet you're wondering about the astrophotography challenge. Well, we've decided to give you until the end of October to get your best pick of the Tarantula Nebula in. Send us the file or a link to the file via email, spaghettificationpodcast@gmail.com, DM or tag us on Instagram @spaghettificationpodcast, or contact us through our website at spaghettification.com.au. Pictures will be featured on our website and Instagram profile, and voting will be open in November for the best photo. The prize for this competition is an amazing pair of binoculars, an essential part of any astronomer's kit, donated by one of our fantastic sponsors, Sidereal Trading.
Did you know Sidereal Trading have a strong emphasis on quality products and service-oriented sales and technical staff? But wait, there's more. Sidereal Trading's key strength is their ability to work closely with customers to achieve the results they desire. So whether your interests lie in nightscape photography, panoramas, wide-field Milky Way, or deep sky nebula and galaxies, Sidereal Trading can supply the astrophotography equipment you need and a free set of steak knives. Visit www.siderealtrading.com.au. Steak knives not included.
We are up to our nebula of the month.
It's the Spider Nebula. It's Tarantula Nebula. And the way I describe it, when you look at it through a telescope, so you know when you kill a spider, not when you squish a spider.
No, I don't kill spiders. I have no idea what that looks like. Sorry.
When you spray a spider with spider spray and they die.
It's the worst way to kill a spider.
And they sit on their back like that. See, no one else can see this. If you get your hand and you clench your open hand but roll your fingers in, you get that dead spider on its back look. That to me is what Tarantula Nebula looks like through a telescope, like a dead spider on its back with its legs crunched in.
So when you look up into the sky, you see cruelty. So tarantula, where do you find it? Where do we look? This is our nebula of the month, so we want everyone to be zooming in on it. What type of nebula is it?
Tarantula Nebula, located on the outskirts of the Large Magellanic Cloud. So it is a hotbed of star formation, that's for sure.
And it actually has a lot of mass in it. So you just said it's in the LMC, the Large Magellanic Cloud.
Yes.
It actually has an eighth of the mass of the LMC. So the LMC is an irregular galaxy, like a galaxy, so full of stars. And this Tarantula Nebula actually has about an eighth of the entire mass of that galaxy inside it, which is pretty huge.
So there's an area in there called R136, which is the starburst region. So in an area less than 1 light year across, which is not a lot from an astronomy point of view, there are more than 40 massive stars containing 50 times the mass of our sun. That's 40 stars in 1 light year across, and there are no stars within 1 light year of our sun. So that sort of gives an example of how many stars are tightly packed in there.
So it's not just that there's lots of stars, there are actually really big, massive stars in that area as well. So just to the north of that, about 30 parsecs to the northeast of this cluster, R136, there's actually a huge, really bright type of star called a Wolf-Rayet star. VFTS 682 has a mass of about 150 times the sun in this one star, and it's about 22 times its radius. It's enormous. And it's about 164,000 light years away. It has a visual magnitude of 16.08, and it is 3.2 million times more luminous than the sun. Its surface temperature estimated at 52,200 Kelvin.
So it's beach weather.
The sun's surface temperature is about 5,500 Kelvin. This star's surface temperature is 52,200.
Absolutely beach weather. Pack your sunglasses, grab your towel.
Starscreen.
Some people want to have a tan, so they don't need their Starscreen.
It's not going to live long. I mean, I call the normal sun-like stars and, smaller the accountants. But if this was an accountant, this would be the one that is seriously involved in some nefarious business because it ain't going to live long. So this entire nebula, the Tarantula Nebula, has more than 800,000 stars and protostars, so newly forming stars. And they're often enshrouded or covered by dust. So we can really only see them in the heat or the infrared wavelengths. You might not realize how many stars are there when you look at them with optical wavelengths, but when you look at them with an infrared filter or camera, you actually notice that there's a whole bunch of other stars. This is, just short of 1 million stars and protostars in this one little nebula, which explains why it's so massive.
Did you know there's a supernova in Tarantula?
Oh, really?
Yeah. SN 1987. It's a Type 2 supernova.
Remnant. Yeah, that's a really famous supernova, yeah.
Yes, discovered in 1987.
That might be why it's called the supernova 1987.
1987A. It peaked at its brightest point in May of 1987. It was the first supernova that modern astronomers were able to study in detail as well.
So let's go back to the nebula for a minute. It's an H2 region. So what that means is a bit different from the planetary nebula we talked about last week, which is the remains of a star that has puffed out its outer layers and is glowing because of the light emitted from the white dwarf. This is an H2 region, which is basically a bunch of gas that is glowing because of all the newly formed stars inside it. And that light actually hits the gases of this nebula and makes the nebula excited. So it does what's called photoionizing. Photo from photon, so the light hits the gas, and then ionize means that the electron is actually kicked off from its atom. So the hydrogen atom, the electron is kicked off, so it's just a proton now. And that's what H2 regions are. And you see this light when that electron eventually comes back to the atom, recombines, and gives off that extra energy that it has. So these H2 regions actually glow with their own energy. They've absorbed the energy of the nearby stars, and the gas itself is glowing, and which is really cool. And so the Tarantula Nebula obviously has these big legs of glowing gas, which, you know, you've described so well as the dead spider. So Orion is our very, very bright nebula that we can see that everyone knows about. Well, if you don't know about it, it's time to go and look at Orion. If you put Tarantula in the position that proximity to Earth, it would fit 60 full moons across.
Yes.
And it would actually cast shadow. It is that bright.
And it's that big.
To give you some idea of how enormous, both in a spatial and luminosity and energy perspective in a sort of way, this nebula is worth your time.
Absolutely worth your time. And it's nice and high at the moment too, and getting higher.
So Mark, we're coming up to that section where we're going to talk about something in depth. And we're going to go for quakes.
Space quakes.
Well, I thought first of all, maybe we should start by talking about why quakes happen on Earth. Any ideas?
Why do quakes happen on Earth? Tectonic plates?
Yeah, so there are a bunch of reasons. A couple of them are man-made, so we can make quakes happen. There's actually a construction site up the road from me at the moment that
is making
makes
earthquakes?
Small tremors. Yes. And so they're driving pylons into the earth, and you can definitely make the local area shake. And that's definitely something they can do with explosives as well. So that's one way of doing it. Another one is through collapse. So if you've got a cave or a mine site where a whole bunch of earth just suddenly collapses in, which is not a nice thing to happen, you can create an earth tremor that way. Basically, whenever a whole bunch of material moves suddenly and causes a wave to go through the solid material of the earth. They're sort of man-made generally. Another type of earthquake is generally associated with volcanics. So you get all that hot material in the earth's crust, and there's lots of shakes, and the vibrations cause earthquakes. But the one that you're thinking about is definitely related to tectonic plates. So of course, those plates that sort of are in the crust and they move up and down and sideways. They
Shifting
travel
around.
Yeah, shift around the surface. I suppose the surface, I'll use that term loosely, of the earth. So earthquakes on Earth, you know, you get your P waves and your S waves, your primary and your secondary waves, which shake it up and down and then shake it sideways. So you've got your compression and your transverse waves, which come along and destroy everything and can create tsunamis. Basically, all quakes come down to the release of energy.
Pressure.
Exactly. So you get something pushing on something else or pulling apart from something else, which creates tension or compressive forces in the rock. And eventually this gets so high that it needs to release. And so you get all types of interesting quakes over fault lines. So you get thrust faults, which is exactly what it sounds like. Something's thrusting upwards. You've got slip slide faults, and you sort of have material moving across each other. So San Andreas is, I think, like that. So the fault goes one
shear fault line.
Exactly, a shear fault line. So some of them are, you know, heading towards each other and one goes over the other, and some of them go down, some of them go side to side, some of them pull apart. So this is why we get earthquakes on Earth, because we've got a molten core and the mantle is warm and the pieces are kind of sliding around the top. So when we look at Mercury, there are thrusting faults, so regional material, large-scale rocks that are thrust in the air, 1,000 kilometres in diameter and 3 kilometres in height. So there's some serious energy being dissipated here. And there's actually evidence that Mercury is still actually warm inside. So obviously being quite close to the sun, and from its very early days, it would have been molten. And as it's cooling down, it's actually shrinking, contracting as it cools. Yes. And the crust just can't really keep up. And so there's heaps of pressure of one piece of crust on another, which causes this tectonic activity and causes earthquakes on Mercury. And it's actually been fairly recent. So images obtained by NASA's Mercury Surface Space Environment Geochemistry and Ranging
Messenger,
otherwise known as Messenger. Gosh, we're good at acronyms, aren't we? There were some little fault scarps that they found, lots of little cliffs and things, and they thought they must be actually quite young. And so this is only 2015, so this is only in the last 20 years that we've come across this evidence. And it makes it really interesting because we kind of thought that Mercury should be cold and dead by now. And as we'll probably touch on in a minute with a few other planets, we have for a long time thought that tectonic activity is highly beneficial for life. So a source of energy is something we look for life. And we thought that Earth was the only body in the solar system that really had tectonic activity. But seeing it even in Mercury makes us realize that, in fact, it's probably not that unusual. And it at least opens up the possibility that there could be life elsewhere if it relies on tectonic activity.
So I know Apollo 11 put down a passive seismic experiment, which was the first seismometer placed on the moon. But what has that told us?
So Apollo 11 was definitely one of the missions that put down seismometers. Also 12, 14, 15 and 16. So we've been very interested in moonquakes for quite a long time, or if, we want to use your word, spacequakes.
Spacequakes.
And it does actually look like some of these quakes at least are connected with large fault lines that we can still see on the moon through images from lunar orbiters. Apollo 11 actually conducted a passive seismic experiment. So their seismometers were sitting there passively waiting for moonquakes to come along. There's another type of seismic experiment you can do called an active seismic experiment, which is where you detonate explosions on the surface.
Let's just cause an earthquake.
Well, basically, we do it on Earth, we do it on the moon. Yeah. The reason we do it is because quakes are basically compression waves or material waves traveling through solids or sometimes liquids. And so it depends on the type of wave as to what sort of materials it can travel through, whether it can travel through solids and liquids or just solids. So on Earth, secondary waves, S waves, shear waves is what they're called. They're the transverse waves, can actually not travel through liquids. Only primary waves can travel through liquids, so they go through solids and liquids, but then the shear waves, the S waves, can't. And then whenever they get to a boundary between different materials, they change speed and change direction. So we can actually tell some stuff about boundaries, what the sort of material is in terms of its composition, its phase. So is it a liquid or a solid, or what type of liquid or solid? How dry is it? Just by looking at things like delay and amplitude and direction of these waves that travel through solids. So when we do active seismology, it's not just because we want to blow stuff up like Mythbusters. It's because we actually want to know exactly where the explosion was, the source of energy, so that we can then go and look at where we record stuff around the moon or around the Earth, for example, to work out what's in between, which is really, really cool. The only thing with the Apollo missions is that most of the detectors are in the same place.
And we want to blow stuff up. We do.
Oh, yeah, we love blowing stuff up.
So there is there 4 types of quakes for the moon?
Yeah. So there's 4 types of quakes. 3 of them are kind of mild. They're not really that exciting.
Boring ones,
You've got these, boring. So 700-meter deep quakes below the surface. They think these are sort of due to tides. So the interaction between the Earth and the moon, the same thing that causes our water tides on Earth.
Yep.
There's vibrations from meteorites and stuff that's hitting the moon. Of course, the moon doesn't have, an atmosphere, so it doesn't really burn up material. It just hits the surface. So that actually gets recorded on the seismometers. So in fact, some of the quakes that were recorded by the Apollo missions are meteorite impacts. And then you get thermal quakes as well. So if you think about it, the day is 2 weeks and the night is 2 weeks. And so that's a lot of time to get cold. And then when you turn around to face the sun, you've got to heat up again. So the third type of not really exciting quake comes from warming rock. Now the 4th type is quite a shallow quake. So it's between 20 and 30 kilometres. I think the one that hit Melbourne was, 10 kilometres below?
Yeah, 10 kilometres below, yeah.
Yeah, so 20 to 30 kilometres below is quite shallow, but the moon's kind of different from the Earth. So the moon doesn't have a lot of water in its rocks. So with the Earth, with the water in the rocks, the seismic wave goes through and the Earth acts kind of like a sponge because it's watery and it absorbs a lot of the energy. And so it doesn't last more than usually seconds, usually tens of seconds, sometimes minutes, but not much more than that. But on the moon, when these shallow quakes get going, because it's so dry, it's described as ringing like a bell, and it can actually just go round the moon for 10 minutes. Which is pretty insane. So even though these moonquakes are only what we associate with being about 5 or so Richter scale, which is not even a scale we use on Earth anymore, but 5 in magnitude, the fact that they go on for 10 minutes causes a lot of angst amongst people that want to build structures on the moon.
Yeah, it's a bit nastier.
So one thing we need to be looking for in the future is Mars. So Mars quakes are obviously of interest because we hope to be there in the next decade or so. So we need to understand a bit more about Mars quakes. And recently, InSight, an instrument on Mars, has actually detected 3 record-breaking quakes. So the first 2 that it detected a while ago, we weren't even sure if they were real. So scientists actually had to cover up one of the cables and then also dust off a bunch of dust from the solar panels in order for this instrument to continue working.
How did they do that from Earth? That's actually pretty cool. So they've done it remotely.
It was so cool. So there were lots of little specks of dust on the solar panel. And my understanding is that they got the instrument to put bigger particles of dust on the solar panels, and then it made the smaller ones slide off when the big ones slid off, which is kind of cool.
Very cool.
They also instructed earlier in the year the instrument to pile sand, Martian sand, on the cable used for the detection. But so the quake detection in 2019 on Mars was about magnitude 3.7. And
that's pretty good.
Yeah, that was 2019. The one here was 4.2 magnitude. So it was very slow, very low frequency. There was a 4.1 magnitude as well, which was faster and higher. So a higher frequency wave. And a really close 925 kilometres from InSight. And actually they thought that they would see more in this season. But yeah, so a lot of this points to the fact that Mars has been tectonically active quite recently. So even volcanically and tectonically active within the last 10 million years, which for us it's not that long ago that the planets that we think about as cold and dead were actually tectonically active. Shit.
You?
Should.
No.
Because you should.
Absolutely should.
So going with our theme of earthquakes, we posed a question to each other, and that was, can earthquakes actually change Earth's position in space? So its spin, its poles, and all that sort of thing. And it turns out, Mark, that earthquakes actually can and do change Earth.
This is where you have to educate the 5-year-old drunk astronomer. And this is one of those things that I don't know that I probably should know.
Well, I think it's amazing that you can have an earthquake. So we think about the size of the Earth and you zoom in to an area that's had an earthquake and you see a little star or a dot on a map.
Or, like a circle. Yep.
Yeah, and radiating outwards, and that's sort of regional, I guess. And the thought that that movement overall can change the distribution of mass on a global scale and therefore change a bunch of parameters like the length of a day on Earth, I think is pretty mind-blowing. So, for an example, on December 26th, 2004, a huge earthquake struck off the coast of the Indonesian island of Sumatra.
Yep, the Boxing Day earthquake, yep.
Either Christmas or Boxing Day tsunami.
Yep.
Followed this earthquake. It was colossal, destructive, and as I said, the tsunami just made it even worse. Unfortunately, nearly 230,000 people died. There was widespread destruction, mostly because of the tsunami, but, the earthquake itself wasn't great either. This one is what's called a mega thrust earthquake, and they occur at points where you've basically got what's called a subduction zone. So you've got one plate that goes underneath another plate, and the plate that goes underneath is usually the oceanic plate. The heavier, denser, waterlogged plate goes underneath the continental plate. In this case, it's the Indo-Australian plate was going underneath the Eurasian plate. So you end up with this friction, and because it's basically convergent, right? It's not easy. It's not like, just going underneath. It's not like a conveyor belt. There's a lot of friction and a lot of stress that builds up there. And what happens in the earthquake is that this stress gets released as energy in a big slip. And this was a 9.1 mag quake along a fault that ruptured about 1,500 kilometres long. And so this was huge.
Massive, yeah.
Massive release of energy. And so what this quake did to Earth, it slightly changed Earth's shape. It shaved almost 3 microseconds from the length of the day and actually moved the North Pole by a few centimetres.
So when you say it shaved 3 microseconds from the Earth day, how does it do that? Is it increasing the speed that we're rotating because of the quake?
Yeah, so it changes the mass distribution, which then changes the rotation of the Earth.
So it sped our rotation up by 3 microseconds.
Yeah, that's made the day shorter.
Wow. And did it change the tilt?
So it shifted Earth's mean North Pole, so geographical North Pole, by about 2.5 centimetres in the direction of 145 degrees east longitude towards Guam.
So it's an inch. It's not a little bit. It's an inch. That's quite large.
Well, it's small compared to the whole Earth, but it's huge compared to just an earthquake, isn't it?
I know it's small, but it's like 3 microseconds, and then you say 2.5 centimetres. To 2.5 centimeters for the whole Earth seems like quite a lot.
Yeah. And so as I sort of mentioned before, it also changed the shape of the Earth. So when we talk about the Earth, we would typically say it's a sphere, but it's really not. It's what we call a spheroid. It's oblate, which means that it's not quite a sphere. It's a little bit fatter at the poles. So you'd be better to sort of think about a hamburger. Squishing down on the hamburger, it's kind of fat at the middle. So this earthquake actually made it more round by about 1 part in a billion. So this shifting material, this change of center of mass made the Earth more round and less oblate in this small amount of time that it occurred. It's just incredible.
Yeah.
So it's exactly 2.68 microseconds that the Earth span a little faster.
That's actually pretty cool.
Which is, of course, related to the change in shape. And this is not the first time.
No, I was going to say, well, it's not the first time, and it's clearly not going to be the last time either.
No. This seems to happen quite a lot, and it speaks to this intricate relationship between what we would consider local geography, local geology, our place in local space.
Actually impacting us further.
Yeah, if someone was watching from Venus or Mars.
They could detect that for us, yeah.
So actually, you know Fukushima?
Yes, yep, the power, yep.
The meltdown of the
with the power plant, yep.
Yeah, so that was in 2011.
God, that's so long ago when you think about it. It doesn't feel like it was 10 years ago.
I know, but it feels like yesterday. God, it was awful. So that was 2011.
Yeah.
The Tohoku earthquake was about Mag 9 and the world's 4th biggest earthquake since 1900. Another tsunami, 39 metre high, and more deaths, so 16,000 people. Unfortunately, nuclear meltdown as well. So it was a tragedy. It actually affected the globe as well. We had icebergs breaking off in Antarctica due to the seismic waves. Norwegian fjords actually splashed backwards and forwards. And then, of course, we had the wreckage, washing up on coastlines. And it actually shortened our day by 1.8 microseconds and shifted the Japanese island of Honshu 2.4 meters to the east. So it's not uncommon, and it really speaks to this, relationship, this intricate relationship we have with space around us.
So the other earthquake, so they both shortened our day.
Yeah.
So our day is 4.5 microseconds shorter because of those two.
So when you feel like you've got less time to do things,
you actually do have less time to do things. So obviously the next big one my research has led me to believe is obviously the San Andreas fault. The quake that they say that they are going to get, that's going to do similar, probably more than what the 2004 Boxing Day tsunami did if what they say is going to happen happens. Maybe? Different type of earthquake? Or
yeah, different type of earthquake.
Okay, there you go. See, the 5-year-old drunk astronomer is learning something.
No, but it's a great question.
Because I know they talk about the mega quake.
Yeah. So the important part of what we were just talking about are thrust quakes, where the motion is basically vertical, so something's up and down. With San Andreas, the fault is essentially what we call a strike slip. So one piece of material is going, let's say, top to bottom, and the other piece of material is going bottom to top. So you've got this lateral motion where the fault is one part moving against the other, not necessarily one pushing up and over or one pushing down or slipping down from another. And so this is called a strike slip fault normally. So there are 3 things that impact whether an earthquake is going to change the length of our day or the distribution of mass on our planet. The ones that are closest to the equator will have more of an impact on the Earth's spin. And if you think about that, the
hamburger again.
If you put a toothpick in the hamburger and you spin it, you'd be more worried about the lettuce in the inside flying out in the middle areas than, a sesame seed on the top flying off, right? And that's to do with angular momentum, okay? The further away from the equator of the hamburger you move, the less you feel being flung out. And that's exactly the same. An earthquake at the equator makes a big difference to the Earth's day or the Earth's shape. So that's number 1. Number 2, a bigger earthquake, bigger influence. Duh. And finally, the type of earthquake matters. So the ones we're talking about are mega thrusters. So they're thrusting earthquakes where you've got one piece moving vertically up and down in some way. Either it's slipping down with some vertical component or moving up and thrusting up with a vertical component. But the San Andreas one is a side to side, so a strike slip fault. And that seems to produce very little vertical motion. That doesn't actually really change the length of a day. So anything that pushed the Earth's crust vertically changes the length of its day and changes the distribution of mass. But anything that sort of slides across the surface doesn't seem to...
Not so much.
Exactly. So when you look back at history, 2011 in Japan, 2010 in Chile, 2004 Sumatra, all of those ones are thrusting faults rather than the strike slip. Interesting Interestingly enough, actually, Earth's day changes quite a bit. Even though you think, oh, earthquakes have changed it quite a bit, it actually changes every time the Earth's mass is redistributed. So that's tides, wind patterns, and also the liquid outer core circulating.
So we don't really even notice the changes that are happening to us.
No, we don't notice them at all. So don't stress too much.
Kind of just balance each other out. Oh, I'm not stressed by it at all.
Right. For me, it's just a lack of sense of how to spend my time. But anyway, so, it could be important if we try to go to other planets and we miss.
We'd like to give a shout out to our very first Patreon supporter, Mr. Steve Paulson. Thank you, Steve, for your support. It means a lot to us as we begin this journey into the world of podcasting. If anyone else out there would like to support Spaghettification, please head to our website at www.spaghettification.com.au and follow the links to our Patreon page. Sidereal Trading can supply the astrophotography equipment you need. Visit www.siderealtrading.com.au.
Hey, subscribe, sponsor or support us. Head along to our website at www.spaghettification.com.au. That's spaghettification.com.au and follow the links to subscribe. Photo submission for the Astrophotography Photo of the Month is through our website. Check us out on YouTube and Instagram and keep an eye out for submitted photos which need your vote on our Instagram page. We now have a Patreon, which gives you special access to extra behind-the-scenes content, bloopers, and potentially a guest spot on the podcast. If you'd like your name or business featured in a podcast, hit us up at spaghettificationpodcast@gmail.com.